Alright, so today we're going to be working on how we can use sampling to draw inferences about a population. Alright, so basically what this means is we're going to take some sort of sample, right, and we're going to make a conclusion about a bigger population based on that sample. Now before we get into that, let's just revisit a ratio question that we answered before. Alright, because we're gonna basically take the same method used to answer this question, and we're gonna use it to answer questions on statistics. Alright, so Jesse's car used 12 gallons of gas to travel 456 miles. How many miles did his car travel per gallon of gas? Alright, so if you remember how we answered this question in the past, we always started out with a proportion, and the way we set up that proportion is what you know equals what you want to know. All right. So right now, the only thing that we know is, well, 12 gallons of gas, and he traveled 456 miles. So let's make a ratio with that. So 12 gallons over 456 miles. And we're going to set this equal to what we want to know. Well, we want to know how many miles would he travel on 1 gallon of gas, right? So per usually means one. So I'm going to put 1 gallon of gas, and I'm making sure I keep my units aligned, right? Gallons over miles equals 1 gallon over X miles. All right, so now I have a proportion, and to solve this proportion, we're going to need to cross multiply. So it's going to be 12 times X equals 456 times 1. And 456 times 1, that's just 456. All right, so now we have a one-step equation. We're going to divide 12 on both sides, and X is going to equal 38 miles. All right, so for every 1 gallon of gas, Jesse is able to travel 38 miles. All right, so let's use this method to answer a statistics questions. All right, so Adam took a survey of 48 out of 200 students in the 7th grade to see if they were going on a summer vacation. 30 of the 48 students said they were going on a summer vacation. What is a good prediction of the number of 7th graders who are going on a summer vacation? All right, so if you remember how sampling and populations work, a population is basically the entire group of people that you want to survey. In that case, it's the 200 students. Now, we're not going to actually survey the 200 students. Let's assume that the 200 students, that's too many students for us to survey. So instead, we're going to take a smaller sample. In this case, Adam took a sample of 48 students, and 30 of them said they were going on summer vacation. So we can start the same way as the question we did earlier, right? So what you know equals what you want to know. We know that with his sample, 30 were going, said they were going on vacation. So I'm just going to label that 30 vacation. And that was out of the 48 total that he surveyed. And we're going to make a prediction about the rest of the 200 students without actually having to survey all of them, right? Based on this sample that we took, all right? So once again, we know that 30 said they were going on vacation. Out of the 48 total, we want to know how many are going on vacation. So we're going to put X vacation out of the 200 total, all right? So we're using this sample to make a prediction about the actual number of 7th graders. Alright, so let's cross multiply. That's going to be 48 times x, and then 30 times 200. It's going to give us 48x equals 6,000. Let's divide 48 on both sides. And x is going to equal 125 students going on vacation. Right, so out of these 200, it's expected that 125 students are going to go on vacation based on this sample that Adam took earlier. Now, we can also answer this question with a ratio table. All right, so let's set that up over here. So once again, we know that 30 are going on vacation out of the 48 sampled. So the two units we need to focus on is, first of all, the total, right? And how many are going on vacation. So let's set up a ratio table. So we have vacation and total. All right. And the only thing we know so far, is pretending that we didn't already just answer the question using a proportion, we know that 30 are going on vacation out of the 48 total. All right. And we want to know how many are going on vacation out of 200 total. Now, the reason I didn't put it in the middle here is because I want to get the unit rate first. So the unit rate, as we know, we can scale that up to 200. I could take the 48 and scale that up to 200, but I don't want to deal with fractions or decimals. It's easier to just deal with the unit rate. All right, so we need to get a 1 here, so then we can take that 1 and scale it up to 200. All right, so what do we have to do to 48 to get 1? Well, we have to divide this by 48. So that's going to give us a total of 1. And we're going to do the same thing for the 30 here. So 30 divided by 48 gives us 0.625. Right? Now, whatever we do to get 1 to 200, we have to do the same thing to the top here. So what do you have to do to 1, or what number do you have to multiply to 1 to get 200? Well, 1 times 200 gives us 200, and then 0.625 times 200 gives us 125. All right, so out of the 200 students total, it's expected that 125 students are going to go on vacation. All right, and that's the same thing that we got over here. So we get the same answer. Oops. All right, so I'll give you a couple of minutes to answer this question. Okay, so Ariel surveyed a random sample of 90 registered voters in her hometown. She asked them if they were in favor of building a new park. The results are shown in the table below, right? So out of the 90 registered voters in total, 63 voted yes and 27 voted no. Based on the results, about how many people out of the 15,500 registered voters would be expected to vote yes in favor of the new park? Right, so you can use any of the two methods that we used in class to answer questions like this, or any of the two methods that we just showed for the other question. Um, I'm going to go with a proportion. Right, so remember, the way we set up proportion is what you know equals sorry, what you want to know. Right? And right now we know that out of the 90 registered voters that she surveyed, 63 said yes. So let's set that up as a ratio. So 63 said yes over the 90 total. And we're going to set it equal to what we want to know, right? We want to know how many are going to say yes. So X yes over the 15,500 registered voters. Right? So make sure your units are lined up. Yes over total equals yes over total. Alright, so now we can cross multiply. So that's going to be 90 times x equals 15,500 times 63, which is 976,500. Now we can need to divide by 90 on both sides. And we get x is equal to 10,850 yes. So based on this ratio that we know, right, 63 said yes out of the 90, out of 15,500, this is how many that are expected to say yes, 10,850. So that means our answer is going to be C. All right.